Okay, let's dive straight into an incredible new tool that is completely transforming how developers understand large code bases. If you've ever found yourself hopelessly lost in a sprawling, undocumented repository, you already know the pain of trying to trace exactly how all the pieces fit together. So today, we're unpacking CodeNav in this explainer. It's a prototype system that gives you the sheer analytical power of AI, but without compromising your privacy or blindly uploading your entire life's work to the cloud. Right, so this is the massive challenge we're all facing today with AI coding tools. You want those deep, context-aware answers that a large language model can provide, but you absolutely cannot afford to expose your proprietary source code, trade secrets, or client data to external servers. It's just a huge security risk. And honestly, that exact friction is what CodeNav is designed to solve, running entirely locally.
For this explainer, we have a quick roadmap. 1. Meet CodeNav. 2. Building the memory graph. 3. Grounded AI code answers. 4. Visualizing your code base. And 5. The development roadmap.
Section 1. Meet CodeNav, and specifically, the tech stack.
So, what exactly is CodeNav? Basically, it's a local-first code navigation assistant built to help you understand and explore massive code bases efficiently. It's a multi-part tool combining a command line interface, a local memory service, and a grounded AI chat that lets you seamlessly explore the graph-style structure of your code. The absolute crucial point here is local first. You retain complete control over your code and its metadata. Literally nothing leaves your machine unless you explicitly tell it to. The tech stack here is actually beautifully modular. CodeNav uses Node.js and TypeScript for the user interface and CLI, making it super accessible if you're a web developer. But under the hood, it leverages Python through a local fast API bridge to handle a really complex memory service called Cognee, running locally on port 8000. Combine that with an Express server for the dashboard on port 8080 and a Groq client wrapper to manage the chat, and you get a very deliberate, smart hybrid approach. Section 2, building the memory graph, focusing on the core loop. This system operates on a very specific 4-step core loop, which is pretty much the beating heart of the MVP. First, it parses your project using TypeScript AST analysis. It uses a parser called tsmorph to systematically extract all your files, classes, functions, and imports. It maps out their relationships, what contains what imports what. Then it converts this into a structured memory model, stored locally using Cognee. This creates a highly searchable knowledge graph of your entire codebase. So when you ask a question, it retrieves only the exact right context, shares just that context with Groq for a grounded answer, and then represents everything visually in the UI. To make this work, CodeNav normalizes all that raw code data into a really strict schema called the CodeNav memory record. Every single piece of information gets a deterministic ID and a specific kind, like a file, a symbol, a relationship, or a summary. It rigidly keeps track of file paths and exact line numbers. Because it forces the data into the structured format, it can safely cache everything locally, right inside your .codenav cache folder. Absolutely no sending raw files blindly to the cloud. Section 3. Grounded AI code answers. It's all about accuracy first. Think about standard LLMs for a second. Usually, you have to dump your entire project into the prompt, which just devours tokens, exposes your source code, and frankly often leads to those frustrating hallucinations where the AI invents functions that literally don't exist. CodeNav completely flips that script. It doesn't scan the whole project at query time. Instead, it explicitly asks the local cognitive memory to recall specific, structured context first, just the most relevant code snippets, summaries, and relationships. It then uses that specific data to ground the Groq language model's answers with actual citations. So when you fire off a question, CodeNav neatly bundles these specific details into a super compact prompt packet. We're talking file paths, precise line numbers, concise symbol summaries, and relevant snippets, all strictly limited by a token budget. This highly curated context goes to Groq, basically forcing the LLM to generate a context-aware response based only on the actual source code you gave it. The answer comes back with references to the relevant files and locations, making it incredibly easy to verify. No more guessing if the AI is making things up. Section 4, visualizing your codebase through the dashboard views.
Now, CodeNav isn't just a background tool. It brings this data to life through a slick, Express-powered web dashboard. You get your main chat interface to interact with the AI assistant, complete with those source citations and a really handy context drawer. You also get a massive visual memory graph, a files view to inspect what's been indexed, a memory inspector to dig into the raw underlying records, and a health panel to make sure your parser and Cognee bridge are running smoothly. The memory graph is absolutely fascinating. It visually distinguishes between files, classes, functions, and modules. You can literally click and expand a file node to see its contained symbols, view what it imports, and inspect its summaries and raw snippets right there in the browser. This level of transparency is huge because it totally eliminates the black box feeling of AI. If the AI gives you an answer, you can look at the exact same graph and memory records the chat used to generate it. You know exactly why it said what it said.
Section 5, the development roadmap in their strict core-first plan.
Because this is an MVP, the developers have mapped out 6 very distinct, disciplined phases. Phase 1 is all about safety, getting secrets out of config files. Phase 2 locks down that memory schema we talked about. Phase 3 solidifies the local Cognee endpoints. Phase 4 perfects the context sharing with Groq. Phase 5 polishes the UI graph. And Phase 6 ensures the core terminal commands are rock solid. This sequential roadmap heavily prioritizes reliability over hype. The local first bridge and explicit context retrieval have to work perfectly before anything else happens.
To keep that focus super tight, they are strictly supporting only these essential commands for now. You have init to set up your config, start to launch the local servers, doctor to check for missing dependencies like Python or API keys, ingest to parse the project, and query to ask questions. That's it. They are intentionally pausing development on flashy features like exporting, importing, or tech debt analysis until these core commands function flawlessly from end to end. As the documentation plainly states, the most important work is to complete the core loop before expanding into the larger command and product surface. And honestly, that disciplined approach is exactly what you want in a complex developer tool. It means that when they do move down the roadmap to add things like semantic search, multi-project selection, or cross-language support via TreeSitter, all of those features will be built on an absolutely flawless local-first foundation. By combining local TypeScript AST analysis, structured memory retrieval via Cognee, and grounded AI reasoning via Groq, CodeNav is delivering faster, incredibly reliable code exploration while keeping the codebase and all its metadata securely under your control. It's a genuinely exciting glimpse into the future of private development tools. So the question I want to leave you with today, are you ready to take back control of your code metadata while still unlocking the sheer power of AI? It is definitely time we stop blindly trusting the cloud with our code bases. Thank you so much for joining me on this explainer, and I highly recommend keeping a close eye on this project as it evolves.